Hi, it's Mrs. Pope, and today we're going to talk about polynomial functions. We're going to evaluate them and identify general shapes of their graphs. I've put a few examples here. These are the ones that you should know off the top of your head, what a constant graph looks like, what a linear graph looks like, and what a quadratic looks like. And I'll just put a couple of examples so you'll know maybe what the equations would look like as well. So if we have a constant function, an example might just be y equals 2. That's just going through the y-axis. Of course, because it's horizontal, it's y equals. If it were vertical, it would be an x equals some number. The degree here, there's no degree because we don't have a variable or any degree. And then the leading coefficient, well, there's nothing else here but a 2. So let's look at this example. Let's say we had a linear function. Maybe the example would be y equals 1/2 x minus 2. That looks like it goes through negative 2. The degree here, remember the degree is the highest exponent, so we would have a degree of 1. And the leading coefficient, once it's in standard form, is the coefficient of the term that holds the degree. So it would be 1/2. And an example here, maybe we have 5x squared. Let's do y equals. So y equals 5x squared minus 6x minus 2. The degree would be 2 because it's a quadratic. And the leading coefficient would be 5. So these are just ideas that you can get just from looking at it. You should be able to tell all of those. You can't tell the exact equation, but you should be able to look at an equation and know that the graph looks something like that. All right. So the other ones that you may know, not that you know them off the top of your head, but these are good ones to be familiar with. A cubic function. Well, a cubic function may look something like this. The example would be maybe something like 8x cubed plus 12x squared minus 3x plus 1. So it's a cubic function. The degree is, of course, 3, and the leading coefficient would be 8. Now let's look at a quartic function. They can look very different. I'm just giving examples. An example here, maybe you have 1/2 x to the 4th. 1/2 x to the 4th plus x cubed minus 2x squared minus 3x minus 5. So it has I just put all of them in there so you could see. The degree here is going to be 4, and of course the leading coefficient is going to be 1/2. And then finally a quintic. These can look all kinds of different ways, but one example is if we went, let's see, up, down, up again. I know it's an odd degree, so they need to go in odd in opposite directions for the end behavior. So let's say we had y equals 2x to the 5th power. That's in my way. Yeah, let's say we had y equals 2x to the 5th plus x to the 4th plus 3x cubed minus 2x squared minus x minus 5. The degree here is going to be 5, and the leading coefficient would be 2. So we can go on and on and on and on and on, but mostly in this course we're going to stop at quartic. We will look at a few quintic, but mostly we're going to be having quartic and flow. So the general polynomial equation is, and this looks crazy, I understand, but this is from your book, we need to know, it's the a to the n of x to the n plus a to the n minus 1 times x to the power of n. Basically what this is saying is, just like here, if this were a 5th degree polynomial, then you would have your 5th term. So this was x to the 5th, that would be the 5th one. Then you'd have the 5 minus 1, or the 4th term, 3rd, 2nd, all the way down to the constant. So that's all it's stating. This one starts at 4, 3, 2, 1, none. So that's where this would go. This is 5, 4, 3, 2. So it's just stating that your general polynomial would be the highest degree first, then the next, and the next, and the next, all the way down to the constant. Where a sub n is not 0, so, and a sub n minus 1, a2, a1, and a0 are all real numbers. So all of these need to be real numbers, and this can't be 0. We don't want to have anything to the 0 power leading it, because then it wouldn't be a polynomial. And notice that n is also a non-negative integer. So the exponents here cannot be negatives. So keep that in mind. All right, example 1. We're going to now stop looking at the graphs. We're going to actually evaluate some of these. So we want to find function values of variables. So Here we're going to find f of 3c minus 4, if f of x is x squared plus 2x minus 3. So here, notice I've replaced the x. If this said f, this is not x anymore, it's now f of 3c minus 4. So everywhere there's an x here, I'm going to replace it with 3c minus 4. So f of 3c minus 4 is equal to 3c minus 4 squared plus 2 times 3c minus 4 minus 3. So everywhere there was an x, I plugged in 3c minus 4. So we have a little bit of work here to do to simplify it, but this is the way it starts out. So you want to take your original function, is the way we did it, and then plug the other function in there. So let's say this is just what it's going to equal. We don't have to do anything over here anymore. That's just what we're equaling. So here we're going to need to FOIL this out. 3c minus 4 times 3c minus 4 plus 6c minus 8 minus 3. So if you FOIL this out on your own, you would get 9c minus 12c plus 16. And I'll write that out. 9c squared minus 24c plus 16, yeah, and then plus 6c minus 11. So if we simplify all that, we end up with 9c squared minus 18c plus 5 because of the 16 minus 11. So I just took a little shortcut here, but you don't have to. You can FOIL it out, write all of your terms, and combine them, and you should end up with the same thing as I did. Okay, one more example today. So this one is a little harder. It says find g of 5a minus 2 plus 3g of 2a if this is our function. Yikes, there's a lot there. So my hint is find each piece separately, then combine. So what we're going to do, we're going to do piece 1 and piece 2. So we're going to make this piece 1 and this piece 2. We'll find those, and then what our answers are, we'll just add them together. So piece 1, find g of 5a minus 2. So anywhere there's an x, I'm going to put 5a minus 2. So that will be 5a minus 2 squared minus 5 times 5a minus 2 plus 8. We would FOIL this out, combine, and distribute the 5. So if you FOIL this out, you end up with 25a squared minus 20a plus 4 minus 25a plus 10 plus 8. So FOIL that out. That's how I ended up. That should say 20, not 2a. I said 20, I just didn't write it. I went ahead and FOILed that. Don't forget to do that. First outside, inside, last. And then distributed the negative 5. Negative 25a minus 10, and then add the 8. So when you combine all of your like terms and put everything together, you'll end up with 25 a squared. Let me combine all my like terms. Minus 45a plus 22. So this is the first part. Let's just hold on to that for a second and figure out the second part. So the second part here, 3g of 2a. So we're going to take 3 times g of 2a. So the way we would write that, we would have 3 times, and now we need to do g of 2a. So we need to plug in 2a everywhere here. So we have 2a squared minus 5 times 2a plus 8. So this 3 is on the outside and g of 2a on the inside. So let's figure everything out on the inside first, and then we just have to, don't forget to multiply everything by 3. So 3 times 4a squared minus 10a plus 8. Yeah? And then we can distribute our 3. So we should have 12a squared minus 30a plus 24. And this would be our second piece. So piece 1, piece 2, and notice the original equation said to add them together. So if we add these together, 25a squared minus 45a plus 22, let's add that to 12a squared minus 3a plus 24. Add them up, and that should be your final answer. Should end up with 37a squared. Did I miss something? 45a. That should be a 30a. Maybe you caught that. That should have been a 30a. 30a. That looks better. So minus 75a, and add those together, we should have plus 46. So this should be your final answer. You may need to watch that one again, but remember, you are responsible for your own learning.